हेलो स्टूडेंट्स, आज हम लोग डिस्कशन करेंगे कुछ बचे हुए टॉपिक अल्कली मेटल्स के। और ये बचे हुए टॉपिक क्या क्या है उसको पहले समराइज कर लेते हैं। ऑक्सीडेशन स्टेट, मैग्नेटिक बिहेवियर, मोबिलिटी ऑफ अल्कली मेटल आयन। तो हम लोग पहले प्रॉपर्टीज को डिस्कस कर लेते हैं। ऑक्सीडेशन स्टेट, जितने भी अल्कली मेटल्स हैं उनका कॉमन ऑक्सीडेशन स्टेट +1 होता है, क्योंकि उसके आउटर मोस्ट वैलेंस शेल में 1 इलेक्ट्रॉन मोर देन इट्स ऑक्टेट कन्फिग्रेशन होने के कारण ये एक इलेक्ट्रॉन को रिलीज करता है और इसका ऑक्सीडेशन स्टेट +1 होता है। इसके अलावा इसका जो मैग्नेटिक बिहेवियर है, जितने भी अल्कली मेटल्स हैं उनका मैग्नेटिक बिहेवियर पैरामैग्नेटिक होता है। पैरामैग्नेटिक होने का मेन कारण क्या है? इसके वैलेंस शेल में एक अनपेयर्ड इलेक्ट्रॉन होता है, जिसके कारण ये पैरामैग्नेटिक बिहेवियर को शो करता है। अब हम लोग आते हैं मोबिलिटी ऑफ अल्कली मेटल आयन। जैसा कि हम लोग जानते हैं कि स्मॉलर द साइज ऑफ द आयन, मोर विल बी इट्स आयनिक मोबिलिटी। लेकिन अल्कली मेटल आयंस जो हैं, जितने उनके साइज छोटे होंगे उनका मोबिलिटी क्या होगा, उतना ही कम होगा। इसका कारण बड़ा सिंपल है कि स्मॉलर साइज होने के कारण हाई हाइड्रेशन एंथैल्पी होता है, और जिसके कारण ये हाइड्रेटेड आयन को फॉर्म करते हैं। हाइड्रेटेड आयन फॉर्म करने के कारण इसका मॉलिक्यूलर मास में इंक्रीमेंट होता है, और उस मॉलिक्यूलर मास इंक्रीमेंट होने के कारण इसका आयनिक मोबिलिटी जो है वो लोअर डाउन हो जाता है इन एक्वस सॉल्यूशन। तो ये तो हो गए कुछ प्रॉपर्टीज जो बचे हुए थे अल्कली मेटल्स में। अब हम लोग डिस्कशन करेंगे अल्कलाइन अर्थ मेटल। अल्कलाइन अर्थ मेटल में कुछ सिंपल इंट्रोडक्शन के साथ हम लोग शो करते हैं क्लास। अल्कलाइन अर्थ मेटल्स किसे कहते हैं? तो सिंपल डेफिनेशन आप लोग लिख सकते हैं, द एलिमेंट for which the last electron enters into s orbital having valence shell configuration NH2 are known as alkaline earth metal, and these elements are belong to group 2 in periodic table. The first element of this group is beryllium, and rest of the elements are beryllium, magnesium, calcium, strontium, barium and radium. So these are the elements which are present in group 2, which is known as the alkaline earth metal group. Now we'll discuss some of the important physical properties of alkaline earth metal, and we'll discuss one by one these properties. The first property is metallic behavior. All the alkaline earth metals are metallic in nature, and on moving down the group, their metallic character get increases because of having tendency to lose the electron, and this can be explained by the fact that as we descending down the group, effective nuclear charge get minimized because of the Stirling effect, and as a result of which the removal of electron become much more easier, and so they have greater tendency to show the metallic character on down the group. But it is interesting to note that alkaline earth metals are less metallic as compared to that of alkali metals. This is due to the fact that alkaline earth metals consist completely fulfilled valence shell configuration, and therefore their removal of electron become much more difficult and more energy will needed to remove that electron responsible for its less metallic character. The second property, which is very important one, that is ionization energy. Alkaline earth metal possesses higher value of ionization enthalpy. The high ionization enthalpy of alkaline earth metals only because of their fulfilled valence cell configuration. Consequently, they needed more energy to remove the electron from their outermost cell, responsible for their higher ionization enthalpy. Third property we'll discuss, that is the magnetic behavior. All the alkaline earth metals are diamagnetic in nature because they do not contain any unpaired electron, and that is why they are diamagnetic in nature. Now we'll discuss about the oxidation state of alkaline earth metal. All the alkaline earth metals shows the common oxidation state of +2 because they have contained two more electron in their valence shell than their octet configuration. So they have tendency to lose two electron, and so they show the +2 oxidation state in most of their compound. Now we'll discuss about atomic and ionic radii. Both atomic and ionic radii of alkaline earth metal goes on increasing on descending down the group. The answer is again very simple, that on moving down the group, as the atomic number get increases, shielding effect get maximized. Consequently, the effective nuclear charge get decreases, and the distance of outermost electron from the nucleus get increases, responsible for their higher atomic and ionic radii. Now we'll discuss about the another property, and that is electropositive character. As we have mentioned earlier that group 2 elements are metallic in nature, which means alkaline earth metals having tendency to lose the electron, and they show the electropositive character, and their electropositive character get increases as we moving down the group. This is again due to the fact that on moving down the group, due to settling effect, effective nuclear charge get decreases, which means the outermost electron will be less tightly held by the nucleus, and their removal become much more easier, responsible for high electropositive character on moving down the group for these elements. But it is interesting to note, if we compare the electropositive character of alkali metals and alkaline earth metals, then we found that alkaline earth metals are less electropositive in nature as compared to that of alkali metal. This is because of having completely fulfilled valence cell configuration. Another very interesting property that we'll discuss right now, that is flame coloration. Like alkali metals, alkaline earth metals also having tendency to impart color to the flame. But it is interesting to note that first two elements of alkaline earth metals like beryllium and magnesium having no tendency to show the color in the flame. This is because of the two factors. They possess smaller size and completely fulfilled valence cell configuration, and that is why the jumping of electron from lower energy to the higher energy become much more difficult, and therefore they do not have tendency to show the color in the flame. But on moving down the group, as their size get increases, distance of outermost electron from the nucleus get increases due to the shielding effect, effective nuclear charge get decreases, and the outermost electron become less tightly held by the nucleus. Under this condition, the thermal energy is sufficient to excite the electron from lower energy level to the higher energy level, and difference of energy is emitted in the form of visible region of light, responsible for the flame coloration of other alkaline earth metals except beryllium and magnesium. So these are the properties, the general common properties of alkaline earth metals that we have discussed today, and hope you enjoy the class. In our next class, we'll discuss about another very interesting topic about the S block element, that is diagonal relationship and abnormal behavior of first element of group 1 and group 2. Thank you.